We have synthesis. That means putting things together. You have two or more substance, elements or compounds, combining to make a single compound. So here's the general form. A plus B makes AB, combines together. So here's some examples. H2H plus O, hydrogen and oxygen, makes water, putting the hydrogen and oxygen together. We have magnesium and oxygen to make magnesium oxide. We have sodium and chlorine to make sodium and chloride. So hopefully we'll see magnesium oxide in class. You've seen it already, but hopefully you get to do that in class. It'll be fun. So you get to see a synthesis. OMG, Mr. J, did you hear about oxygen and magnesium? Yes, I did. Oh. Next. Okay, so now we have decomposition, which is the opposite of synthesis. Decomposition is breaking apart. So here we have something together, A and B, breaking apart into A plus B. So notice it's the exact opposite of synthesis. So we have water breaking up into H and O. We'll be doing that in class too. That's fun. We have magnesium oxide breaking up into magnesium and oxygen. That's hard to do in class. And then we have sodium and chlorine, sodium chloride breaking up into sodium and chlorine. Also hard to do in class. But this one is kind of fun. We can watch a video on it online. I'm not going to do it in class. Is ammonium dichromate. It's pretty orange. You light it on fire and it breaks up into nitrogen, water, and chromium-3 oxide. So we don't want chromium oxides around the lab, so that's why we're not going to be doing that one. But if you want to, I'm sure there's a cute one on YouTube you can find. We'll be doing other fun things like this one, where we have hydrogen peroxide. We add a catalyst to break it up into water and oxygen, also known as elephant toothpaste. So that's pretty cool. We're going to be doing it in class, not humongous. If you want to watch humongous, like bathtub car size, great videos on YouTube. Watch them. But we'll be doing it in class. It's fun to do it in person, but we're doing it a lot, smaller scale. Okay. Dude, I think you're overreacting. Dude. Next, we have combustion reactions. Combustion reactions are burning things. So there's a nice picture of combustion. So you're burning a hydrocarbon in oxygen. So things like gasoline, kerosene, propane. So your car burning gas, that's combustion. And having a nice little barbecue, combustion is really nice this time of year. Okay, so these is the general form. C's and H's plus oxygen makes carbon dioxide, water, and heat. So this could be any C's and any H's. That's why it's X and Y. Oxygen is always going to be there. Carbon dioxide is always going to be there. And H2O is always going to be there. And of course, it's going to give off heat. It may not be in the equation because it's heat. So if you see oxygen going to carbon dioxide and H2O with something with C's and H's, that is most definitely a combustion reaction. That's the general form, which is very similar to the actual. So what do you need for a fire? And here's a Bunsen burner going. What do you need for a fire? The fire triangle. Smokey the Bear says you need three things for the fire triangle. You need fuel, something for it to burn. You need oxygen, something to burn with, and then something to spark it. So a spark or a light. So if you can get rid of the oxygen or get rid of the fuel, you put out the fire. Or just don't be playing with sparks near those. Okay. Now, this time of year, this is a very important slide. We have our combustion reaction. CHs and O2 make CO2 and H2O we had before. So in our class, the combustion reactions will always be carbon dioxide and water. But, incomplete burning causes byproducts like carbon monoxide, CO. So here's a car in a parking lot or parking, don't run a car a long time in an enclosed space like, but it's cold, Mr. J, I need to warm it. Don't warm it up in the garage with the door closed. Do not. Why? Because it makes, instead of carbon dioxide, it makes carbon monoxide. And carbon monoxide, this time of year, you should definitely have one in your house and make sure the battery is working, because you're using a lot of combustion to warm up the house. Your stove is, your heater is heating. Now, if you try to warm up your house using a stove or the oven, don't recommend that, because if you don't have enough air coming in, which means you didn't crack your window, and why would you? Because it's letting the cold air in, then you're going to get carbon monoxide, and then that's not going to be good. So you might be warm, but you'll be dead. So I recommend not having a barbecue in the house, and make sure when you're warming up your car, don't be doing it in the garage with the door closed. Make sure the door's open and the tailpipe is heading out. That's why, if you notice, when you go get your oil change or whatever, they have the doors open, or they put a tube on the end of your exhaust, so they get the combustion, the carbon monoxide doesn't form. The carbon dioxide goes out. That's why you have like the flue in your house, to go up to get rid of the gases. Next, we have single replacement. So single replacement is where one replaces the other. So notice here, A is by itself, and then it goes in. So now B is by itself. So they switched places. So frequently these will be metals. So here we have zinc going in and copper coming out. And here you can see copper is coming out. You can see copper right there. So we'll be seeing this one also in class. And we'll also be seeing what makes this happen. And that has to do with the reactivity series, the activity series of metals, which we will spend a bunch of time on very soon, but not today. So it's a list of the most reactive metals, and will it replace the next one? And the question is, if it's more reactive, it will replace it. So I gave you the heads up on what we're doing next. Okay? Next is a double replacement reaction, where 2 and 2 combine, they switch partners, and I'll slide up here so you can see it. So they switch partners, and you make a precipitate, and there it is. So there could be other products, but the one that we're going to see the most is a precipitation reaction. So example, we have 2 things, silver nitrate, plus 2 things, silver chloride. Notice they're both aqueous, meaning dissolved in water. And then they're going to switch partners. So the sodium switches, and now it's with the nitrate. That is soluble. And the silver is with chlorine now, and that's the precipitate. How do you know it precipitates? I'll show you in the next slide. So this precipitation reaction does go. Okay, so how do we know if it's soluble or not? Use a solubility table like this. And what you can do is you say, oh, let's see, ammonium and bromide is soluble. So that is soluble. Calcium and carbonate is insoluble. That means it makes a precipitate. So we'll give you the chart, and we'll do that when the time comes. Okay, and here's the precipitate coming out, forming on the bottom. Okay, and of course, if you're not part of the solution, you are part of the precipitate. So here's the super summary. And this is great for you visual folks. So let me try to get myself out of the way here for now. So synthesis, overview slide. We got 2 or more elements combined. And you can see A plus B makes AB. You can see the 2 combining. Decomposition, the opposite, is where 2 break up into individuals, or 1 breaks up into individuals, and you can see that there. Single replacement, 1 goes in, 1 comes out. So here the green guy is single, and now the red guy is single. 1 in, 1 out. Usually that's metals, but there are other examples. We have double replacement, where you got 2 and 2, they switch partners, and then you have 2 and 2. So it's like do-si-do, they switch partners. And usually you'll get like a precipitate, that's the common reaction. You'll see some other ones too, like giving off water or a gas. And then we have combustion, which is my favorite, where we're burning something in oxygen. So we have C's and H's, doesn't matter how many C's and H's, plus oxygen makes CO2 and H2O. So you're always going to see the oxygen, you're always going to see the CO2, and you're always going to see the H2O. If you don't see those three in that order, oxygen going in, carbon dioxide and water are products, they could switch. The combustion is with C's and H's. So if you have oxygen, or you have carbon dioxide, or you have water as a product that doesn't make it combustion, you have to have all of those guys together for it to be combustion. And in my class, CO2, complete combustion, will be the only option. Okay, so now, for those people who not visual people and want the little charts, here's the chart. So we have a synthesis reaction, A plus B, AB. We also have the sodium plus chlorine, make sodium chloride. So synthesis. Here we have decomp. AB breaks up into A and B. Sodium chloride breaks sodium chlorine. Single displacement or single replacement. Watch out, it means the same thing. So just be aware that they interchange those words. They do that replacement to displacement. So A plus BC makes AC and B. So one goes in, one comes out. Zinc is going in, copper is coming out. One in, one out. Double displacement, 2 in, 2 out. The 2 out, one of them happens to be a precipitate. Could be something else, but we'll see a lot of precipitates. And of course, the last one, combustion reactions. We've got C's and H's plus oxygen makes CO2 and H2O. And any letter number of C's and H's will be possible. Okay, so now we get to practice which one is which.